Hello everyone, welcome to my channel. Today we'll again continue the topic integration. So last day we have solved some problems of integration. Today we'll also again solve the problems of integration. So here we'll start with question number 1. So first question on the screen. So the question is like this: integration of cot x by root over of sin x dx. So this is the first one. It is given cot x by root over of sin x dx. Now how to find the integration of this one? Now for this one, look at this. This is cot x. Now we know cot x can be written as cos x by sin x, and here is root sin x dx, like this. Okay, so it is given cot x by root sin x, and you can see cot x can be written as cos x by sin x. Now we know one thing is that derivative of sin x is cos x. So here we will use that substitution. Okay, so here sin x, there is the sin x. So I am taking sin x equals to z square. Why z square? Because we can see there is a square root. So I am taking sin x equals to z square. Now differentiate both sides. Sin x will become what? Cos x dx, and z square will become 2z dz, like this. Okay, so here you can see cos x dx, this one cos x dx, this one is what? 2z dz. So that means we replace that value, so it will become like this: integration of 2z dz divided by, here it will be sin x. Sin x means here z square, and root over of z square will be z. So z and z will be cancelled out. That means 2 will go there, and it will be z to the power minus 2 dz, and z to the power minus 2 integration, you know the value, so that will be x to the power n formula. So z to the power minus 2 plus 1, that means minus 1 by again minus 2 plus 1, that is minus 1 plus c. So that will be minus 2 by z. Now what is z here? The value of z is here. From here we can see the value of z is root over of sin x. So that means here it will be root over of sin x plus c. Done. Okay, so this is question number 1. Now we'll move to question number 2. So question number 2 is like this. It is given, next one, question number 2. So question number 2 is like this: integration of dx by e to the power x plus 1. Now this one, this is also a very good question. So e to the power x plus 1. Now how to solve this type of questions? So we can see there is e to the power x plus 1. So what we will do is that, so here you can see there is nothing in the numerator, there is only 1. So solve this equation, solve this type of integration. What to do? We can see there is e to the power x. Now that means we have to multiply both numerator and denominator by e to the power minus x. So that means we multiply both numerator and denominator by e to the power minus x. Now if it was e to the power minus x, then you have to multiply both by e to the power x, like this. So what will happen? It will become e to the power minus x dx divided by, now multiply. Now this one will be multiply this one, e to the power minus x into the power x, that will become 1 plus, now e to the power minus x into 1, that will be e to the power minus x. That, now it is very easy. Next thing is that we have to take it as z. Okay, so substitution, we have to take the denominator here. Let 1 plus e to the power minus x equals to z, like this. Now differentiate this one, that will become minus e to the power minus x, because derivative of 1 will be 0. So e to the power minus x, that will be minus e to the power minus x dx, it will be dz. Now from here you can see what is the value of dx. Dx will be dz by minus e to the power minus x. Now put the values here. If I put the value here, it will become integration of e to the power minus x by z, and dx, what is the dx here? Dz by minus e to the power minus x. So minus e to the power minus x will be cancelled out. So that will be minus 1 by z, integration of this one dz. Now integration of 1 by z, what is integration of 1 by z? That will be log mod z. So that means minus log mod z plus c. So that will be minus log mod. So here you can see z. Now what is the z here? The z was 1 plus e to the power minus x. That means it will be 1 plus e to the power minus x plus c. That's all. Okay. So this is equation number 2. Question number 2. So for this type of question, whenever in the denominator there is only e to the power x or e to the power minus x, we have to multiply like this. Okay. So here you can see it is only e to the power x plus 1. That's why you have to multiply numerator and denominator by e to the power minus x. Now if the denominator was e to the power minus x plus 1, that means you have to multiply by e to the power x like this. Okay. Now question number 3. We'll move to question number 3. Okay, we'll try to solve as many questions as possible. So now question number 3. So question number 3 is like this: integration of cos 2x by cos x plus sin x whole square, this one dx. Now how to solve this one? Okay, now this is also easy. Look, first cos 2x. Now cos 2x, there is a formula. What is the formula? Cos square x minus sin square x. This is the formula of cos 2x. And the denominator, what is the denominator here? Cos x plus sin x whole square. This is the denominator, dx. Now a square minus b square. What is the formula of a square minus b square? A plus b. This is a plus b into a minus b, like this. And the denominator here, what is the denominator here? Cos x plus sin x whole square dx. Now that means 1 will be cancelled out. 1 cos x plus sin x is cancelled out. So like this. So it will remain like this. Cos x minus sin x, it will become like this: cos x minus sin x divided by cos x plus sin x. Now what will be the integration of this one? Okay, so look properly. So what will be the integration? Now look at the denominator here. So here derivative of cos x. So here you can see derivative of cos x is what? Minus sin x. And derivative of sin x is here cos x. That means the derivative of the denominator is coming the numerator. Now if derivative of denominator is coming the numerator, the integration will be log mod denominator. This is the formula. Okay, so whenever the derivative of the denominator is coming the numerator, that means it will be log mod the denominator. That will be the answer. Okay, so this is question number 3. Now we'll move to question number 4. Next one, question number 4. So what is question number 4? So question number 4 is like this: tan to the power 4x dx. Now this one, tan to the 4x dx. First pause the video and try this one, then look at the videos. Okay, so this is given tan to the power 4x dx. Now what will be the integration of this one? Tan to the power 4x. So tan to the power 4x can be written as tan square x into tan square x dx, like this. Now 1 tan square here. Now this tan square, any one tan square, can be written as sec square x minus 1, sec square x minus 1 into tan square x dx, like this. Now multiply this one. So if I multiply, it will become like this: x square x into tan square x dx, okay, minus 1 into this one, 1 into tan square x, that will become tan square x dx, like this. Now this is suppose equation 1. So there are two parts we are getting here: integration sec square x into tan square x dx, and next part is integration of tan square x dx. So we'll do the first one. First one, it is given integration of sec square x into tan square x dx. Now how to solve this integration? To solve this integration, first we have to let tan x equals to z. So here I am letting tan x equals to z. That means if I differentiate this one, it will become sec square x dx equals to dz. Done. So from here you can see it will be integration of, so here you have to put the value here. So it is coming sec square x into tan square. Tan square can be written as z square, and dx is what? Dx is dz by, from here you can see dx is what? Dz by sec square x. So that will be dz by sec square x. Sec square and sec square will be cancelled out. That means z square. So integration of z square will be z cube by 3 plus c. Now what is the value of z here? Tan x. That means tan cube x by 3 plus c. So that will be the answer. Okay, this is the first part. So don't use a c here, we can use a common c here. So here that is a tan cube x by 3, that will be the integration of this one. You can write it as plus c1 also. Okay, now the next part is tan square x. So how to find the integration of tan square x? So in the earlier video I also mentioned how to find the integration of tan square or cot square. So tan square x, we know there is no formula for tan square x in integration, but tan square x, there is a formula sec square x minus 1 dx. Now what is the integration of sec square x? The integration of sec square x is tan x, and integration of 1 is x plus c. Okay, so tan x minus x plus c. This is the integration of tan square x. So you don't need to write c here now. Okay, so from 1, what will be the answer? So for the first one, the answer is here tan cube x by 3. Tan cube x by 3. Now look at here, the next part is here minus of this one. That means minus of tan x minus x plus c. So that will be the answer. Okay, so this is question number 4. Now we move to question number, before that, tan to the power 4x dx, same thing, try this one. Okay, try this one, integration of cot to the power 4x dx. So that will be done by same way. Okay, now we'll move to question number 5. Now question number 5, integration of dx by root over of x plus 1 plus cube root of x plus 1, this one. Now how to solve this integration? Integration of dx by root x plus 1 plus cube root of x plus 1. To solve this equation, first look at here, what is the power here? Power is here half, and here the power is 1 by 3. So here it is 2 and here it is 3. So what is the LCM of 2 and 3? The LCM of 2 and 3 is 6. That means we have to let x plus 1 equals to z to the power 6. That means whatever be the power, first take the LCM. So 2 and 3 here, so the LCM is 6. That means z to the power 6. If there was 2 and 5, that means you have to take LCM of 2 and 5. That means z to the power 10 we have to take, like this. Okay, now differentiate. So dx, it will be dx, and 1 will be 0, and z to the power 6, it will be 6z to the power 5 dz. Now substitute these values here. So it will become like this, 6z to the power 5 dz root under of z to the power 6 plus cube root of z to the power 6, like this. Okay, so it will be integration of 6z to the power 5 divided by, first root under of z to the power 6, it will be z to the power 3, and cube root of z to the power 6, that will be z square dz, like this. Now from the denominator, if I take z square, it will become z plus 1 dz, like this. Okay, so from the denominator, if I take z square, it will become z plus 1, this is z plus 1, and this will be dz. So here z square and z to the power 5 will be cancelled out, so that will become 6z cube divided by z plus 1 dz, like this. Okay, now 6 is a constant. If 6 go outside there, that will become 6 integration of z cube, and that will be plus 1 minus 1. We have to write plus 1 minus 1, and the denominator is there z plus 1 dz. So here 6 integration of, separate this one, z cube plus 1 by z plus 1 dz minus 1 by z plus 1 dz. Okay, Now z cube plus 1 can be written as 1 cube. So a cube plus b cube formula. So what is the formula? The formula is a plus b into a square minus ab plus b square, like this, and the denominator is here z plus 1. Here it is dz minus 1 by z plus 1, that will be log mod z plus 1. So here z plus 1 and z plus 1 will be cancelled out. So integration of z square minus z plus 1. So integration of z square, what will be the integration of z square? That will be z cube by 3 minus z. So integration of z will be z square by 2 and integration of 1 will be z, done, and that will be minus log mod z plus 1 plus c, where z equals to, where z to the power 6 equals to what? X plus 1. Okay, that means z equals to x plus 1 whole to the power 1 by 6. Now you can put the value here and we'll get the result. So that will be the answer. So this is question number 5. So now we'll move to question number 6. Okay, so question number 6. Now we'll write some questions here. We'll do like this. Number 6, question number 6. So what is the question given? The question is given like that: integration of e to the power 2x by 1 plus e to the power x. This is the question number 6. Next, question number 7. So what is question number 7? Question number 7 is given like this: integration of sine 2x divided by a square plus b square sine square x whole square dx. That is question number 7. Question number 8. The question number 8 is like that: dx by root under of 1 plus root x. This is question number 8. Now question number 9 and 10. So question number 9 is like this: cosec x into log cosec x minus cot x. Cosec x minus cot x dx. And now question number 10: sine 2x divided by sine 5x into sine 3x dx. Okay, so those are the question we will solve now. 6, 7, 8, 9, 10. The first, it is question number 6. Now how to solve this question? Question number 6. So it is given 1 e to the power 2x by 1 plus e to the power x. So question number 6, e to the power 2x by 1 plus e to the power x. Now here the numerator is not 1, it is e to the power 2x. So first what we need to do is you have to use a substitution. So let e to the power x, suppose I am letting e to the power x equals to z. Now differentiate this one, e to the power x, it will be e to the power x dx, and that will be dz. So from here you can see dx. What is the dx here? dz by e to the power x. Now put the values here. So that will be e to the power 2x by 1 plus z, and dx is what? dx is dz by e to the power x. Now divide this one. If I divide this one and this one, so there it will be only e to the power x by 1 plus z dz. Now what is e to the power x here? The value of e to the power x is here z. So that means integration of, that will be integration of z by 1 plus z dz. Now put these values here, z by 1 plus z. Now how to do this one? Now look, if the powers are same, now you can see here the power of z is 1 and the denominator is also power of z is 1. So if the power is same, try to write numerator as a form of denominator. That means z can be written as 1 plus z minus 1. The numerator can be written like this: 1 plus z minus 1. Okay, and the denominator is here 1 plus z. Now from here we can write, separate this one. So that will be 1 plus z by 1 plus z minus 1 by 1 plus z and dz, like this. So 1 plus z will be cancelled out, that means 1. So integration of 1 will be what? Integration 1 will be z minus 1 by 1 plus z, that will be log mod 1 plus z plus c, like this. Now here z, what is the value of z? E to the power x, and here will be log mod 1 plus e to the power x plus c. So that will be the answer. So this is question number 6. So question number 6 done. Now question number 7. Again look at here, sine 2x is there. So a square plus b square sine square x whole square. So you have to take this one as z. So here I am taking, so from this, so it is given what? Integration of, I think it is given integration of sine 2x. Okay, so it is given integration of sine 2x by a square plus b square sine square x whole square. So here also you have to use a substitution. So what is the substitution here? A square plus b square sine square x. We are taking this one as z. So let a square plus b square sine square x, that one equals to z. This is the substitution. Now do the derivative later. Okay. So derivative of a square will be 0. Then that will be b square, and sine square x will be 2 sine x, and that will be sine x will be cos x dx equals to dz. Now 2 sine x cos x, what is the value here? Sine 2x, that means b square sine 2x, and that is dx equals to dz. That means dx will be dz by b square sine 2x, like this. Now put the values here, so it will become integration of sine 2x divided by z square. Now dx can be written as dz by, so it can be written as dz by b square sine 2x, b square sine 2x. So sine 2x cancel out, so b square will go there, and it will be 1 by z square. So 1 by z square can be written as z to the power minus 2 dz. So that will be 1 by b square, z to the power minus 2 means z to the power minus 2 plus 1, minus 1 by minus 1 plus c. That means minus 1 by b square z plus c. So b square z, we know the value of z, just put the value here. So that will be minus 1 by b square z, the value of z is a square plus b square sine square x plus c, like this. Okay, so this is the way to do question number 7. Now move to question number 8. Now this is a good problem, integration dx by root under of 1 plus root x. Okay, so here integration of, this is question number 8, dx by root under of 1 plus root x. Now how to solve this one? So for this one, first look at here, this is root x. So let root x equals to z. That means x will be what? X will be z square. Okay, so I am letting root x equals to z, that means x will be z square. Now differentiate this one, so that will be dx, and differentiation of z square will be 2z dz. Now put the values here. So integration of dx is here 2z dz divided by root under of 1 plus root x. Now what is the value of root x? The value of root x is here z. So root under of 1 plus z. Now again we have to use another substitution. What is the substitution? Here you can see root under of 1 plus z. That means this one 1 plus z, here 1 plus z, will take it as v, and since it is a root, you have to take it as a v square. Suppose let 1 plus z v square. Why it is square? Because here is a square root. So now differentiate this one, that will be dz, and v square will be 2v dv, because one differentiation will be 0 and z will become dz, and v square will be 2v dv. Now put the values here. So value of dz, we got the value. So it will be integration of 2z by root under of 1 plus z. So root under of v square, and here dz, what is the value of dz? That will be 2v dv. So here integration of 2. Now z, what is the z here? Now what is the value of z? From here we can find z is v square minus 1. So from here we can write v square minus 1 by v, and this is 2v, and this will be dv. So that will be 2v dv. So that will be 2v dv. Now from this 2v and v will be cancelled out. So here you can see 2 and 2, that means 4. 4 will go there, and v square, what is the integration? V cube by 3, and integration of 1 will be v plus c, like this. Now since those are the substitution, we have to put the values here. Now v, what was the value of v here? Now from